All right, so section 2.3 is on circles, and I think my graphs are going to go downhill really, really far as we go through this section. We're going to be asked to graph circles, and quite honestly, it's not very easy for me to graph circles, so just everything I graph is supposed to be a circle, but nothing will look so nice. And I'm not expecting perfection when you go to do your homework or answer test questions. So on this sheet, it gives me the kind of the essence of a circle. An equation that's going to graph to be a circle has to be of the form x minus h squared plus y minus k squared equals r squared. And if I have something written specifically in that form, then the number after the minus sign is the x coordinate of the center in the x parentheses. The number after the minus sign in the y parentheses is the y coordinate of the center, and the square root of the number to the right of the equal sign is the radius. And it says that right here, that h, the number after the minus sign in the x parentheses, is the x coordinate of the center. K, the number after the minus sign in the y parentheses, is the y coordinate of the center, and the square root of that r is the radius. And then xy is any generic point on the circle. So that's kind of all we need to know to get started in this section, but there's going to be obviously subtleties and I don't know, things that make the section hard. But the first 8 problems in this section just want us to get used to going from having the information that describes a circle, specifically its center and its radius, and to go with that information to create an equation of that particular circle. This is a hard section to use my calculator to generate graphs because of this y being buried in a parentheses. In order to graph on my calculator, the y needs to be solved for. And it would be a lot of work to solve for the y, so I'm probably not going to do too much on my calculator. So the first 8 problems just want me to get used to using the formula x minus h squared plus y minus k squared equals r squared. And again, when I look at a problem by itself, just looking at a problem isn't going to tell me what I need to do to solve the problem. I need to read the instructions. The instructions say write the standard form of an equation of a circle with given radius r and center hk. So I have to have the standard form of a circle equation either memorized or at my disposal in order to do any of these questions. So each one of these problems want me to do 2 things. They want me to sketch a graph, and they want me to find an equation. It turns out that I could sketch the graph even if I don't have the equation. So let me do that first, just so we're not confusing the two. If you have the information that tells you the center of the circle, and that's what this is, the center is the point 5, negative 4, and the radius of the circle, the radius is 4, you can graph it even if you don't know the equation. And the way I would graph any circle is first I plot the center. So I'm going to graph the point x equal to 5, y equal to negative 1, 2, 3, 4. That's my point 5, negative 4. And usually I mark that point because it's nice to see the center of a circle labeled. And then to finish up the graph, I'm going to use the radius. And from the center of the circle, I'm going to go, in this case, because the radius is 4, I'm going to go left 4, right 4, up 4, down 4. And each time I do that, I'm going to mark a point. Those are all going to be on the boundary of my circle. So like for this circle here, I'd go up to the edge of the circle, I'd go right to the edge of the circle, I'd go down to the edge of the circle, and I'd go left to the edge of the circle, and then I'd actually draw that circle in. So what I'm going to do is give myself some anchors. I'm going to give myself 4 points along the boundary of the circle, and then I'm going to connect those points with something that kind of looks like a circle. You'll notice even as I'm tracing over a circle that's there, my graph isn't very circular. When I get into the homework, my graphs are going to get way worse than that. So I've plotted the center, 5, negative 4. The radius is 4. So I'm going to go from that point, left, 1, 2, 3, 4, right, 1, 2, 3, 4, up 1, 2, 3, 4, and down 1, 2, 3, 4. I need to draw something that more or less looks like a circle. Because these boxes aren't really squares, you'll see that they're a little bit longer than they are tall. I'm going to get a distortion in my graph. In order to use graph paper and get a really nice graph, each of the boxes needs to be a square. So when I go to draw this, it's going to look less like a circle than I'd really like it to look, but it is what it is. So that's really about as good as it's going to get, and that doesn't really look super circular, but I'll live with it. So that's part of what I need to do for number 2. I did the sketch a graph of a circle. The next thing I need to do is write the standard form of the equation of the circle, and that's super easy because all I'm going to do is into this equation, I'm going to plug h equal to 5, I'm going to plug y equal to negative 4, and I'm going to plug r equal to positive 4, and this is going to give me x minus 5 squared plus y minus negative 4 squared equals 4 squared. And so immediately, if I was given this equation, this is classically standard form of the circle. The number after the minus sign in the x parentheses is the x coordinate of the center, which is 5. The number after the minus sign in the y parentheses is the y coordinate of the center, which is negative 4. And the number to the right of the equal sign that's being squared is the radius. So this would be considered the standard form of an equation of a circle. And in this perfectly standard form, I could look at the equation and know exactly what the center is. If I take the time to simplify this, because it's just, generally we don't leave double negatives and we don't leave exponents that we can clear easily, then you start to not see the center so much. So if I rewrite this as the standard form of my circle as x minus 5 squared plus y plus 4 squared, getting rid of that double negative, equals 16, this is still a circle with a radius of 4 and a center of 5, negative 4, but this version of the circle as opposed to that version of the circle, it makes it a little less obvious what the radius in the center is, because in the y parentheses there's not a minus sign, and in the formula the y coordinate of the center is the number after the minus sign, and when there's not a minus sign, either I could take the time to rewrite it in standard form or I can just switch the sign. Generally, if I'm given a simplified form of an equation of a circle, I say the center comes from the numbers in the x and the y parentheses, and I just change their signs. So the x coordinate of the center is going to be positive 5, the y coordinate of the center is going to be negative 4, and if the number to the right of the equal sign doesn't have a square like it did in the standard form, I square root it to get the radius. So sometimes, more often than not actually, we'll be given an equation of a circle that's in a simplified version of the standard form. We still should be able to back into what the center and what the radius of the circle is. Alright, so that's way overkill, but hopefully you can do problem 1. And you probably can do the next problems 3, 5, and 7 and not have to watch me do the next few problems, but I'll go ahead and do these anyways. So for problem 4, I'm going to graph it first, and to graph it, I'm going to plot the center. And the center of a circle is defined as the point HK. I'm going to plot the point negative 6, positive 3. So here's negative 6, and there's positive 3. The radius is 5, and I'm going to use that radius to get the rest of the graph by going up, down, left, and right 5. So it's a little bit harder. If I go right 5, that's 1, 2, 3, 4, 5. Left 5, 1, 2, 3, 4, 5, because each of my grid marks is 2, and then up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. And I just can't draw these very well. And that's my graph. Again, it looks more like a football than it does a circle. And now, so this is the part of the instructions that said sketch a graph. The other part of the instructions said write the standard form. So I need both parts for my answer. And to write the standard form, I'm just going to use the standard form of a circle equation, x minus h squared plus y minus k squared equals r squared. And for h, I'm going to plug -6. For k, I'm going to plug +3 because I'm told h and k are -6 and +3. And then for r, I'm going to plug in 5 because I was told that as well. And this is going to have me go x minus -6 quantity squared. Should be plus right here, not minus. If you have a minus, you get something called an ellipse as opposed to a circle. Plus y minus 3 quantity squared equals 5 squared. This is technically the answer that is maybe best. This is for the standard form of this circle, but we need to be able to look at a circle that's not in quite standard form and still be able to pick it off the center and the radius. So this is completely standard form. The number after the minus sign in the x parentheses is the x coordinate of the center. The number after the minus sign in the y parentheses, 3, is the y coordinate of the center. And the number that's being squared, 5, is the radius. But more often than not, you're not going to leave a double negative or an exponent on a number that can be gotten rid of. So a better answer to the standard form would be x plus 6 squared plus y minus 3 squared equals to 25. And then to get the center, you'd have to change the sign of the 6 to -6 for the x coordinate of the center. Then I think change the sign of the -3 to +3 for the y coordinate of the center, and square root the 25 to get 5, the radius. So these two equations are equal to each other. They're both considered the standard form of a circle, and I don't know if one is, probably the top one in some sense is better because it perfectly gives you the information that you need without having to do any trickery, but the bottom one is more likely what you're going to see just in practice. All right, I'm not so happy with this purple marker, so I'm flipping markers. I thought I'd write in a fun color today, but it's just not thick enough, so I'm going to switch colors for the rest of the video here. All right, so it's a little bit trickier to do problem 6. I'm going to graph it and then find the standard form. So I'm going to plot the center, which is x equal to 1, y equal to 3, and then go up a third, down a third, right a third, left a third, and then a third is really, it's not a full way between the two bars that I have here, or the two vertical lines or horizontal lines. It's just a third of the way, so I'm going to call that a third up or right, that a third left, less than halfway, that a third up, this a third down, and I draw my circle. So that would be the sketch a graph part of number 6. And now when I go to find my equation, again, I'm using the standard form, x minus h squared plus y minus k squared equals to r squared, and an answer for the standard form that's not simplified, that's the other thing that's required, would be x minus 1 squared plus y minus 3 squared equals to 1/3 squared. Because I'm squaring a fraction, I'll put it in a numerator or in a parentheses. And so this is okay. Then you can see the center is the 0.13. The number after the minus signs in each of the parentheses are the x and the y coordinate of the center, and the number being squared is the radius. But it would probably be better if I clean up that right-hand side, on the left-hand side, I don't have any double negatives I'm worried about, so I'm not going to worry about getting rid of those. But to square a fraction, to square the 1/3, you have to square the 1 and square the 3. 1 squared is 1, 3 squared is 9. So if I wrote x minus 1 squared plus y minus 3 squared equals 1/9, I'd have an answer that's equally correct. They're both considered in standard form, but this is kind of a simplified standard form. All right, one more problem each in these groupings. And have at it here. So my radius is 8, and I start with the point 0,3. So I'm going to plot the point 0,3. And then I'm going to go right 8, the radius, 1, 2, 3, 4, 5, 6, 7, 8. Left 8, 1, 2, 3, 4, 5, 6, 7, 8, because my axes are marked by 2. Up 8, 1, 2, 3, 4, 5, 6, 7, 8. And then down 8, 1, 2, 3, 4, 5, 6, 7, 8. And then again, draw something that's reasonably circular that actually goes through the points would be nice. So that's my sketchograph. Now for my equation, I'm going to use that standard form, x minus h squared plus y minus k squared equals r squared. And for h, I'm going to plug 0. And for k, I'm going to plug 3. And then for r, I'm going to plug 8. And my answer for the standard form, because I was asked to do two things, sketch a graph and find the standard form, is going to be x minus 0 squared plus y minus 3 squared equals to 8 squared. And that one I can completely see the center 0, 3 and the radius is r. But it would be better if I clean this up. X minus 0 squared can just be written as x squared without a parentheses. And the 8 squared can be written as 64. More often than not, when you're going to be given an equation of a circle, it's going to be in a reduced standard form, and you need to be able to look at something that's in reduced standard form and understand what the center and the radius is. So this one, when there's just an x squared and there's not a parentheses, then the x coordinate of the center is 0. This one, you change the sign of the -3 and get the y coordinate of the center of 3. This one, you square root the 64 and get the radius of 8. All right, next group of problems. Now we're going to get into some real algebra. Hardish algebra, I guess. It could get harder than this, I guess, but I'm not making it so much harder. So, so it says rewrite the problem so it's written in the standard form of a circle. A standard form of a circle, again, is x minus h squared plus y minus k squared equals r squared. So there's only one x, it's inside a parentheses with a square. There's only one y, it's inside a parentheses with a square. And to the right of the equal sign, there's the radius squared. For each of the problems between 9 and 18, the first step to get the problem rewritten is to group the x's and group the y's. So first, to get this problem rewritten so I can see that it actually graphs to be a circle, is I'm going to group the x's and the y's, and I'm going to move the number over. So I'm going to rewrite this problem by getting it kind of set up. I'm going to add 4 to both sides, and when I add 4 to both sides, that's going to give me a 4 on the right-hand side of the equation. That feels like the radius is going to be 2, but unfortunately it's not. On the left-hand side, I'm going to group the x's, right, x squared minus 2x, and group the y's, right, plus y squared plus 4y equals 4. So my first step is just kind of getting the x's grouped together, because these x's somehow I'm going to transform into x minus h squared. The 2 y's somehow I'm going to transform into y minus k squared. And the 4 already looks like an r squared, but it's going to change before long. So after I group the x's and y's and move the number over, I'm going to add a number after the x, after the y, and to keep the equation balanced, I'm going to add two numbers after the 4. Let me slide down to the bottom of my paper. Usually, we give C's for these numbers because that's what we do in intermediate algebra. So I could assign letters to these numbers. I don't know if that's more confusing or not. But the number that I add after the x's, I'm going to say it's a constant for the letter C, and it's the first constant, so C sub 1. The number that I add after the y's, it's a constant, meaning it doesn't have a letter, and it's the second one. I'm going to call it C sub 2. And after the 4, I'm going to add these same two numbers after the 4. If I change these letters to numbers, then the equation will simplify to the original equation. By adding the same numbers to each side of an equation, just like adding 4 to each side of an equation, it changes the appearance of the equation but doesn't change what it equals to. It's completely legal algebra. So now I need to figure out what C1 and C2 need to be. And C1 is going to be the number in front of the x squared term, the x to the first power term, divided by 2, and then squared. C2 is going to be the number in front of the y to the first power term, divided by 2, and then squared. So again, for C1, I look at the number in front of the x to the first power term, I divide it by 2, then I square it. For C2, I look at the number in front of the y to the first power term, I divide it by 2, then I square it. For the C1, negative 2 over 2 is negative 1, and negative 1 squared is positive 1. For the C2, 4 divided by 2 is 2, and then 2 squared is 4. So what I'm going to do is rewrite the left-hand side with an C1 replaced with the number 1, then the C2 replaced with the number 4. And on the right-hand side, I have to add that same C1 and C2. So I'm going to put a 1 in for the C1 and a 4 in for the C2. Now I've taken the problem and I've made it way messier than the original problem. I've got the x's grouped together in a kind of a set of 3, which is factorable. The y's grouped together in a set of 3, which is also factorable. And the numbers to the right of the equal sign are addable. So the next thing I'm going to do is factor my group of x's with its C1, factor my group of y's with their C2, and I'm going to simplify the right-hand side. So step 1 was to group the x's and the y's and move the number over to get the x's and y's to be the only thing on the left-hand side, the numbers on the right-hand side. And then I added a number after the x's, I added a number after the y's, I added that same number after the number on the right-hand side to keep my balance. And now I'm going to factor. X squared minus 2x minus 1 factors into x minus 1 times x minus 1. I'm going to bring down this plus sign, and y squared plus 4y plus 4 factors into y plus 2 times y plus 2. And the numbers to the right of the equal sign, 4 plus 1 plus 4, add up to be 9. I almost have my beginning part done. The beginning part asks me to rewrite the problem so it's written in standard form. This is almost perfect because I can rewrite this as x minus 1 quantity squared, because x minus 1 times x minus 1 is x minus 1 squared, and I can rewrite y plus 2 times y plus 2 as y plus 2 squared, and I can rewrite 9. I can leave 9, 9. This is technically completely okay. This is exactly the standard form, but it's the standard form written with a plus sign in the parentheses, and if you don't like that, you can rewrite the y parentheses with a minus sign, because a plus can be generated by putting it as a double minus. So I can rewrite the y parentheses as y minus negative 2 squared, because double negatives would simplify to be plus. And I can rewrite the 9 as 3 squared. Both of these are considered standard form. The top one's in classic standard form, so I know the number after the minus sign is the x coordinate of the center. The number after the minus sign in the y parentheses is the y coordinate of the center, and the number being squared is the radius. If I wrote it in that form, I could tell you that the center is 1, 2, and the radius is 3. In this form, I'd say change the sign of that negative 1. The x coordinate of the center is positive 1. Change the sign of that positive 2 to negative 2. That will give me the y coordinate of the center. Square root the number. That will give me the radius. So generally, I don't take the time to write something that's in a simplified standard form and write it in a classic standard form to get the pieces that I need to graph. So if something's written in non-simplified standard form, which meaning you have a parentheses with an x quantity squared, a y with a squared, and a number without a square, I change the sign of the numbers in the x and the y parentheses to get the x and the y coordinate of the center, and I square root the number to get the radius. So I've rewritten the problem so it's written in standard form. The bottom version here would be my test question, my answer key to my on my test, but if you rewrote it as the top form, then it's exactly in standard form. You're completely welcome to do that. Now I'm going to sketch the graph. I needed to pick off the center, which is the point 1, negative 2, and the radius is 3, so I'm going to go right 3, left 3, up 3, and down 3, and then draw something that is circle-ish. That's everything for problem 10. Hopefully you could do something for problem 9. The work is a little bit jumbled here, so I'll try to clean my work up as I go through the next problems. So my steps are going to be to group the x's and the y's and move the number over if it needs to be moved over, add a number after the x's, add a number after the y's, add those same two numbers to the right side of the equation, and then factor the trio of the x grouping, factor the y grouping, add the numbers together on the right hand side, and then you're basically going to be home free. So problems 11 and 12 are set up a little bit nicer in that the number that doesn't have the letter is already on the right hand side. So on my first step, to get this written in standard form, I'm going to group the x's and leave myself a little room, and group the y. So on the left hand side, I'm going to put the x squared plus 2x together, leave myself a little room, and I'm going to put the y squared plus 6y together, leave myself a little room, and to the right of the equal sign I have the number 6 that doesn't have a letter, that's all by itself, that's already in a good place. The difference between problem 10 and problem 12 is the number 6, the number that didn't have a letter, was on the left hand side, and I needed to get it to the other side. Alright, so now after my x's, so second, add C1 after the x's, and C2 after the y's, and add, just had a hiccup, so add C1 after the x's, C2 after the y's, add both C1 and C2 on the right side. And eventually I'll replace those with a number. So after the x's, I'm adding the first constant. After the y's, I'm adding the second constant. And to keep my equation balanced, I'm going to do it to the other side, meaning adding C1 and C2. C1 is always half the number in front of the x to the first power term squared. So C1 is going to be 2 over 2 squared. That's going to be 1 squared, which is 1. C2 is half the number in front of the y term to the first power squared. So C2 is going to be 6 over 2 squared, which is going to be 3 squared, which is going to be 9. So now I'm going to change the C1 and the C2 and get this to be x squared plus 2x plus 1. That's changing the C1 to a number. Bring down this plus sign. Bring down the y squared plus 6y. Change the C2 to 9. And on the right-hand side, it's 6, and then plus C1 for 1, plus C2 for 9. Third, factor, that's on the left-hand side, combine on the right-hand side. The factoring on the left-hand side is going to involve factoring the group of 3x terms, the group of 3y terms, and this combining on the right side is going to be adding the 6, the 1, and the 9. These first three terms right here are going to factor into x plus 1 times x plus 1. I'm going to bring down the plus sign that's not boxed. The next three terms factor into y plus 3 times y plus 3. And the number to the right of the equal sign, 6 plus 1 is 7 plus 9 is 16. I'm ready to write the answer for the standard form. So for number 12, the standard, it says to rewrite the problem in standard form. And a version of the standard form can be, instead of x plus 1 times x plus 1, x plus 1 quantity squared, and instead of plus y plus 3 times y plus 3, plus y plus 3 quantity squared equals 16. That's written in a form where I can tell you what the center and the radius is, but if you want it in better standard form, you certainly can take the time and you could rewrite this as x minus negative 1 quantity squared. That double negative turns into x plus 1 plus y minus negative 3 quantity squared, and 16, its square root is 4, so it equals 4 squared. From both of these, I can tell you that the center is negative 1, negative 3, and the radius is 4. Usually I leave it in the kind of simplified standard form, and this would tell me that the center, I go to the x parentheses, change the sign of the number, and get negative 1 for the x coordinate of the center. Y parentheses, change the sign of the number and get negative 3 for the y coordinate of the center. And then my radius is going to be the square root of that 16, which is 4. So if you can pick off the center and the radius from a simplified standard form, you don't need to rewrite it in standard form. If you take the time to put a negative in each of the parentheses, then the numbers after the negative signs are the x and the y coordinate of the center, and the number being squared is the radius. Both of these can tell me the center is negative 1, negative 3, and the radius is 4. So now I'm going to graph it because that's the second part of this. I plot the point negative 1, negative 3, and I go right 1, 2, 3, 4, left 1, 2, 3, 4, up 1, 2, 3, 4, and down 1, 2, 3, 4. Draw something that's circle-ish. You're never ever going to see a real circle. I should probably just bring out like a compass or something, but I just never do. Alright, so the next two problems have some tricks, so get number 11 done and we'll move on and do 13 and 14. So nicely in both 13 and 14, the number that doesn't have the letters already separated. So for 14 to get started, I'm going to group the x terms, and this is kind of unfortunate. There's only one of them. And the y terms. So that x term is really unfortunate, but not horribly unfortunate. A little bit ago, we did a problem that had a center 0, 3, and the equation came out that it just had an x squared in it. It didn't have a parentheses with the x. Because there's just a single x right here, it's going to turn into something like this, where the x corner of the center is going to be 0. There's not going to be much I can do in terms of adding a C1 to the x part, because there is only one x term. The reason I take the time to add a c is because I want to get from 2 of that letter to 1 of that letter. The x's, because there's only one x, I don't need to do anything to improve upon it. I'm going to leave it alone. And in my first step, I'm going to add, I could call it C2, but I'm not going to call it C1 because it's the first, C1 being the first number I'm adding. I'm going to add that to both sides. So I'm going to group the x and y terms. I'm going to add, in this case, only C1. And the reason only C1 is because there's only one x term. I don't have 2 x terms that I'm worrying about. And my C1 is going to be negative 4 over 2 squared. That's going to be negative 2 squared, which is positive 4, and I add that to both sides. So I'm going to leave the x term by itself as x squared, and then I'm going to write y squared minus 4y plus 4 for the y terms, and then on the right hand side I'm going to write 21 plus 4. Now I'm going to factor, and I don't have to factor the x part. I'm just going to leave it at x squared, and I know that the x coordinate of the center is going to be 0. I'll show you how to make that more apparent in a bit. I'm going to factor these. That factors into y minus 2 times y minus 2. And I'm going to combine these. And those combine to be 25. I almost have something that's written for my standard form. So for my answer for problem 14, or an answer for problem 14, the standard form, rewriting the original problem so I can look at it and know the radius in the center, I could say the standard form is x squared plus, and then for this, y minus 2 squared, and for that, 25. That tells me the center is 0, 2, and the radius is 5. If you want to, you can rewrite this x squared as x minus 0 squared. That would still be x squared, because x minus 0 is x. And then plus y minus 2 squared. And then for 25 equals to 5 squared. Both of these, even though this one doesn't have a parentheses and it doesn't have a square with the number, tell me that the center is the point 0, 2, and the radius is 5. In this one, because the number didn't have a square, I'd have to square root it to get the radius. And in this one, the x came by itself, so the x coordinate of the center is 0. The y, I changed the sign of the minus 2 to positive 2 to get the y coordinate of the center. So now I'm going to do the and graph. I'm going to plot my point 0, 2 and go right 1, 2, 3, 4, 5, left 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5. And then I wish I didn't have the and graph part to this, but I do. And again, they're just ridiculously, embarrassingly horrible graphs, but it is what it is. All right, so that should motivate you to do 13. And now I will worry about 16, and you'll worry about 15. And you'll notice that when I go to do my grouping, there's only one y term. The y coordinate of the center is going to be 0. So first, I'm going to do the grouping. And they're already grouped, actually. So I'm going to leave the x squared minus 4x grouped together, leave myself some room. And then I'm going to add, in this case, just C1, because there's y's, there's only one of them, and I don't need to fix up the y's. I need to fix up the x's because there's 2 x's. When there's only a single letter being squared, its center is going to have a 0. And then my C1 is going to be half of negative 4 squared. that's going to be negative 2 squared, which is positive 4. So I'm going to rewrite this as x squared minus 4x plus 4 plus y squared equals 5 plus 4. Now I'm going to factor. I'm going to get x minus 2 times x minus 2 plus y squared. And I'm going to simplify on the right side and get equal to 9. My answer for my standard form, kind of a simplified standard form, would be x minus 2 times x minus 2, which is x minus 2 squared. I'm going to leave the plus y squared, and I'm going to leave the 9. If you don't like that because you don't see the center, it would be okay to write it as x minus 2 squared plus y minus 0 squared equals to 3 squared. In the bottom version, I can immediately see the center is 2, 0, and the radius is 3. In the top one, I changed the sign of the number in the parentheses to get the x coordinate. So the x coordinate of the center is 2. There's not a parentheses, and there's just a single y squared, so the y coordinate of the center is 0. I square root the number 9 to get the radius of 3. So in this problem, when I go to graph it, the center is going to be the point 2, 0, and my radius is going to be 3. So I plot the point 2, 0, go right, 1, 2, 3, left, 1, 2, 3, up, 1, 2, 3, down, 1, 2, 3, and then draw something that's circular that actually is supposed to go through the points. All right, so that should take you through to 15. And then 17, let me just do 17 and not do 18. That way, because they're a little bit different. 17 is actually easier than 18, so I won't do 18. I'll do your homework problem 17. The big trick to problem 17 and 18 is there's numbers in front of the square terms. Circles can't have numbers in front of the square terms, and the way that we're going to get rid of the number in front of the square terms is to divide it out. You could actually factor it out, but when there's an equal sign and there's a common factor without a letter, you can divide the common factor away. So in number 17, which is the one I'm going to attempt to do, I'm going to make it so the square terms don't have coefficients, because you can't have those and get a graph of a circle. And generally, I would factor those numbers out, but when the problem has an equal sign and there's a common factor without a letter, you don't change the graph if you divide each of those numbers by that common factor. So I'm going to start off problem 17 doing that, and that's going to change this to x squared plus y squared minus 4 equal to 0. This is like the first problem in that grouping. I need to have the letters on one side and get the numbers on the other. So the first thing I did in number 17 is I made it so the square terms don't have numbers in front of them. And the second thing I'm going to do is get the number without the letter on the right side. When I do that, I'm going to add 4 to both sides. It's going to give me x squared plus y squared equals to 4. The work that I do to add c's is to make it so that if I have 2 of one letter, it makes it possible to get it from 2 of that letter to 1 of that letter. You'll notice in problem 16, when I only had one y, I didn't have to add a c to the y side, but I did to the x's because there were 2 x's that I wanted to eventually get down to 1 x. In problem 14, the c that I added was only with the y's because there was 1 x, and that's what I want to have. I add a C to something, to the letter grouping, when there's two of those letters. In problem 18, there's only one X and one Y. I don't need to add a number to get it from two X's to one X, nor do I need to add a number to get it from two Y's to one Y's. This is actually done. This is already in standard form because it's perfectly, it only has one X and it's being squared, only has one Y and it's being squared. I would only add a C1 if there were two X's that I needed to factor to get them down to 1x, or if there were two y's that I need to factor to get it down to 1y. If you want to, you can rewrite this as x minus 0 squared plus y minus 0 squared equals 2 squared, and that would maybe be more obviously in standard form. For both of these, I should be able to tell that the center is the point 0, 0, and the radius is 2. So it would be my last graph that I do today. Plot my center and go up 2, down 2, left 2, and right 2, and draw a circle. For the next group of problems, I could actually get the answer without drawing graphs, so maybe I'll have to do some graphing, or maybe I lied. Anyways, there's the answer for problem 17. So you don't have to do that in your homework if you don't want to. The next group of problems, 19 through 26, which is the end of the section, so we only have we each have 4 problems left to do. Take us to the end of the section. Each of the problems want me to find the standard form of an equation, and then it says it may help to sketch a graph before you start your algebra. And yeah, maybe I'll sketch a graph, but I don't. On some of these, I won't have to sketch a graph. So when I go to do problem 20, I want to write the standard form of a circle, and the standard form of the circle, again, it's x minus h squared plus y minus k squared equals r squared. In order to do problem 20, I need to know both the center and the radius, because the center gets split on the left-hand side, the radius goes on the right-hand side. Well, I already have the center. I need to do algebra to find the radius. Once I have both the center and the radius, I can write the equation of my circle. So somehow, I need to find the radius. So let me sketch a graph of this circle the best I can. So it has a center at the point 1, 5. So here's my point 1, 5. And it goes through the point 5, negative 3. So the radius of this circle is that right there. So the circle that's being described is that circle. And I need to find that radius in order to get my equation done, because this right here is going to be my radius. And how can I get a radius? Well, a radius is just the distance between 2 points. The distance between these 2 points is what the radius is, and heck, we have a distance formula to do that, don't we? So the radius is the distance between the center and the point that's given, and the distance formula is exactly what I can use. That's why we did this earlier in the chapter. The distance formula is x2 minus x1 squared plus y2 minus y1 squared under a square root. So the distance between those 2 points, which is the radius, is going to be given by the formula x2 minus x1. I'm going to call that x2 and that x1. So it's going to be 5 minus 1 squared. and I'm going to call that y2 and that y1, so plus negative 3 minus 5 squared. So the distance, which is the radius, is going to be the square root. That's 4 squared, which is 16. This is minus 3 minus 5, which is negative 8 squared. So this one was 4 squared, which is 16. This is minus 8 squared, which is 64. So the radius is 16 plus 64 is 80. That's unfortunate. The square root of 80. The square root of 80 is reducible. Again, when I have to reduce square roots, I usually pull this calculator out. Square root of 80 is 4 square root of 5. To get it by hand, I can say 80 is 16 times 5. So the square root of 80 is the square root of 16 times the square root of 5, which is 4 square root of 5. Now that I think about it, I'm probably being stupid reducing this. Let me pretend I didn't say, oh, I need to reduce this, because it's actually going to be easier if I don't. So in this problem, the center is 1, 5, and the radius is the square root of 80. So now I'm going to find my equation. My center tells me that h is 1, that k is 5, and I know the radius is the square root of 80. I'm going to take these three numbers and plug them into this formula. Turns out that if I don't reduce the r, I'm going to do better than reducing the radius. So the distance between the 2 points is actually the radius. That's what I found is the square root of 80. Now I'm going to plug those numbers into this formula, and my equation is going to be x minus 1 squared plus y minus 5 squared equals r squared, which is the square root of 80 squared. The beautiful thing about the right-hand side, when you square a square root, it cancels out the square root symbol. So my answer for problem 20, it would be absolutely adequate if you said your answer for problem 20 is x minus 1 squared plus y minus 5 squared equals the square root of 80 squared. But if you square the square root of 80, if I did like this, second square root of 80 and then square it, you get 80, because the square root of something squared is just that. And so it would be better if I said the answer was x minus 1 squared plus y minus 5 squared equals 80. Both would be acceptable answers. I can tell you that the radius is the square root of 80, because if it's in a non-simplified form, if it doesn't have the square, you have to square root to get the radius. All right. Hopefully you can do 19 with that motivation. 22 is starting to feel more like a calculus wording. So it says it has the center 4, 1. So my h is going to be 4. My k is going to be 1. I don't know what my r is. So I'm going to draw a picture the best I can. I'm going to draw a circle that goes through the point 4, 1, and it's tangent to the y-axis. That means the graph of the circle touches the y-axis but doesn't cross it. So what it's going to do, it's going to touch right there, right horizontal to the center, and it's going to go like that. So to be tangent to the y-axis, it means the graph of the circle touches but doesn't cross the y-axis. And it's physically going to touch the y-axis at that point right there. And now I have to know how to describe that point. Any point on the y-axis, it's a y-intercept in some sense. Its y-coordinate is always 0. And its x-coordinate, because it's on this horizontal line of y equal to 1 is going to be 1. So now I'm going to find the radius. This is my circle. I drew it tangent to the y-axis, and I'm going to find my radius. And I'm going to find the radius by finding the distance between the 2 points, because that's exactly what the radius is. It's the distance between the center and one of the points on the graph. So the radius is going to be the distance between the 2 points, and that's going to be the square root of the x's squared, the difference of the x's plus the difference of the y squared. So I'm going to go x2 minus x1, which is 4 minus 0 squared, y2 minus y1, which is 1 minus 1 squared, the distance between the 2 points, which is the radius. The first parentheses is going to be 4 squared, which is going to be 16. The second parentheses is going to be 0 squared, which is 0. So it's going to be the square root of 16 plus 0. The distance between the 2 points is the square root of 16, which is 4. The radius for this circle is the distance between those 2 points, which is 4. Now I'm going to take those numbers and shove them into the formula x minus h squared plus y minus k squared equals r squared. And this is going to give me my answer to problem 22. The standard form of the circle that I'm searching for is going to be x minus 4 squared plus y minus 1 squared equals 4 squared. And of course, it might be better if you simplified it a little bit, but you don't have to. If you left it in completely standard unsimplified form, it's completely okay. If you square the 4 and get 16, maybe that's just a tad bit better. All right, let me do your problem 23. That way you just have a little bit less to do in terms of your homework. So 23 is a little bit tricky. So when I look at 23, it says the circle has diameter with endpoints 1, 4 and negative 3, 2, and it doesn't talk about the should probably yank out some graph paper to do this. I don't know if I have any that handy, so I'm going to just fly without graph paper. Doesn't give me the center and it doesn't give me the radius. Let me see if I can do this really so it's understandable. So I'm going to sketch a graph, and what it's given to me is the diameter of the circle, and a diameter is a line that goes through the center of the circle, and the midpoint of diameter is the center. So let me try to plot the point 1, 1, 2, 3, 4. So here's my point 1, 4. And plot the point negative, so I'm doing problem 23 and not ever 24. And plot the point negative 3, 1, 2. So this is a diameter of a circle. The circle's going to actually go through those 2 points. I don't know that's a stellar drawing, but it's good enough. What I'm going to need to do is find the center. And the center of any circle is the midpoint of the diameter. So if you're given a diameter, you can find the center because it's the midpoint, any diameter, in this case this diameter. So a diameter is a line that goes through the center of the circle. Both points on the diameter are on the body of the circle. Let me say that again because I had a hiccup. So the center of a circle is the midpoint of the diameter. The points that make up the diameter are just along the boundary of the circle. So in order to find the center of this problem, I need to know the midpoint. And of course, we did midpoint earlier in this. The center of the circle is going to be the midpoint of this line segment. And we know to find a midpoint is a point, and you get it by taking the x coordinates, adding them and dividing it by 2, and you take the y coordinates, you add them and divide by 2. So the midpoint, which is going to be the center, I'm going to take the x coordinate of those 2 points, negative 3 plus 1, and divide by 2. I'm going to take the y coordinate of those 2 points, add them and divide them by 2. Negative 3 plus 1 over 2 is going to be negative 2 over 2, which is negative 1. 2 plus 4 over 2 is going to be 6 over 2, which is going to be 3. So for this problem, 23, I know it has a center of a point negative 1, 3. Now I need to find the radius. The radius is the distance between the center, in this case it's the point negative 1, 3, and any point along the boundary. I'm going to use the distance formula to find the radius, and the radius I'm going to find is the distance between the point negative 1, 3 and the point 1, 4. If you found the distance between the point negative 1, 3 and negative 3, 2, it's going to be exactly the same as the distance I'm going to find. So now I'm going to find the radius. And I find the radius using the distance formula. And I'm going to choose these 2 points to find the distance between them, because the distance between the center and any point along the edge of the circle is going to be a radius. So I'm going to go x2 minus x1 squared plus y2 4 minus y1 squared. In this parentheses, I have a double negative. I'm going to make that 1 plus 1 squared, which is 2 squared, which is going to be 4. And in this parentheses, I'm going to get 1 squared, which is going to be 1. So the distance, which is the radius, is going to be 4 plus 1, which is the square root of 5. So the radius is that distance, and it's the square root of 5 units. Now I'm ready to write my answer. So when I go to do the answer for problem 23, I had to sketch a graph and draw the diameter, use the diameter to isolate the center. The center is the midpoint of the diameter. I used the midpoint formula. Had to find the radius. The radius is the distance between the center and any point along the boundary of the circle. I picked the easier point that had only positives. Now I have both a radius and a center. Now I'm going to find the standard form, the answer to problem 23. I'm going to use the formula x minus h squared plus y minus k squared equals r squared. And in for h, I'm going to plug negative 1. In for k, I'm going to plug 3. And in for I, I'm going to plug the square root of 5. So my answer to this could be x minus negative 1 squared plus y minus 3 squared equals the square root of 5 squared. And it probably would be better if I simplified that. Although this is an okay answer. If it was your test question, I'd give you full credit. But a better answer would get that double negative out of the x parentheses and say x plus 1 quantity squared. And then the y parentheses I'd leave alone. And anytime you square a square root, you can just drop the square root symbol and write what's under the square root. So this and this are completely fine answers for problem 23. All right, so I won't do 24. The next page has a duplicate question. I'll do 26. Hopefully you don't need to watch me do 26, so you could just pause the video and do 25. But I'll do 26. If you need to watch me do it, watch me do it. So first I'm going to plot the points so I can find the center. So, heck, do I even need to plot it? Yeah, I'll plot it just because if you're visual. So the 2 points I need to worry about are the point 1, 2, 3, 4, 5, 0 in problem 26, and 5, 1, 2, 3, 4. So I'm going to draw a circle that connects those points and draw in my diameter. So right there's my center. My center is the midpoint of the line segment that connects to point 5, 0 and 5, 4. So my center, I'm going to get by using the formula x2 plus x1 over 2, comma, y2 plus y1 over 2. For x2 and x1, they're both going to be 5s. So it's going to be 5 plus 5 over 2. And for the y2 and y1, it's going to be 4 plus 0 over 2. So this is going to give me 10 over 2 and 4 over 2, which is 5 and 2. So for problem 26, the center is the point 5,2. The next thing I need to stumble across is the radius, and the radius is the distance between the center and any of the points on the circle. I'm going to find this distance right here, the distance between those 2 points, which is going to be the radius. So the distance between those 2 points is going to be my radius. I do that by taking the square root of x2 minus x1. In this case, that's going to be 5 minus 5 squared, plus y2 minus y1, in this case 0 minus 2 squared. And then 5 minus 5 squared is going to be 0 squared. 0 minus 2 squared is going to be negative 2 squared. This is going to be 0 plus 4, so it's going to be the square root of 0 plus 4. D is the square root of 4. That I can probably write as 2, so my radius is 2. Now I have everything I need to get the answer for problem 26. I have the center, and I have the radius, and answer for problem 26, the standard form, which is what I'm asked to do. To find the standard form, I use the equation x minus h squared plus y minus k squared equals r squared. An OK answer to problem 26 would be x minus 5 squared, plugging in 5 for the h, plus y minus 2 squared, plugging in 2 for the k, equals 2 squared, plugging in 2 for the r. A better answer to problem 26 would be x minus 5 squared plus y minus 2 squared equals to 4, just because it doesn't have the number with the exponent. And that kind of just feels better. All right, so if that didn't motivate you to do problem 25, you can peek at the solutions manual, or you can come visit me. So we just likely have one section left. Right now there's only one section left. They're talking about adding some stuff to college algebra, and there might be a new section in the future, but I will tell you if there's in class if there's going to be more than one section. So there should just be one section left, and it's a section that's almost identical to what a section that I do in intermediate algebra. It should be review, but it might not feel like review. All right, I'm going to stop the video.